All right, guys, I'm going to walk through some notes on parabolas here. These are some functions that I'm sure we are familiar with in the past, but we might be looking at some kind of new terminology or ways to graph them, other things like that. So the first thing I have up here on this 7.1 worksheet is just an intro to all of our conics. And conics can be formed by taking a plane. So we see in these pictures, there's these yellow planes. So taking a plane and intersecting it with what they call a double napped cone, which is these two cones stacked on top of each other. So if you go straight through, you get a circle. If you go on its side, you get an ellipse, which is like an oval shape. A parabola is if you intersect with like the bottom of that hourglass figure. So we get these parabola shapes we're used to, and so on and so forth. You could get a hyperbola, a point, you could get a line or two intersecting lines. And when you get a plane that goes through the vertex, like these last three over here, we call those degenerate conics. It's kind of like a conic that has never been really generated, right? We just get a line or a point and not these kind of cooler shapes we have for the first ones. So we might be familiar with parabolas from the past, but our standard form this year may be different from what we've seen, and I'm just going to write it here the way the book does, so when we go through stuff, we'll all be similar. So we have two standard forms for a parabola now. We could have an x minus h squared equals 4p y minus k. And let's define a couple of these things, and hopefully kind of your intro sheet you saw these. So for these, p, and I'm trying to see if I have it in this picture. It's pretty hard to see, but p would be the distance. It's like right here from the vertex to the focus. And we'll see more about what the focus does, but that the focus is inside the parabola, and it's important for distance. So hopefully you kind of saw on our intro to parabolas that all the points on the parabola are equidistant from the focus to the directrix, which we will draw in our first example next. All right, and then down here we'll see that if p is positive, our parabola opens up, which we're probably used to seeing like a regular x squared parabola. And if p is negative, our parabola opens down. All right, another important thing to note in this is that hk would be the vertex. All right, for our second standard form over here, it's when we have a sideways parabola, and that would just be when x and y and their respective vertex points flip. And the same thing, p is the distance from the vertex to the focus, and hk is our vertex. It's just now a horizontal distance instead of a vertical distance. All right, so I'm going to go through one example down here, and then you guys are going to try out the others. Maybe I'll do one more just for the sake of getting another one in there. And we're going to see the first thing we need to do with these equations. So here's our equation right here, is put it in standard form so we could identify everything. So to get this in standard form, I'm actually going to, I'm trying to see if I got rid of these fractions. I chose not to. So the first thing I just did was actually factored out the 1/12 just from the x terms to get that x squared by itself. So then I'll have x squared minus 6x, and I left this 13/4 alone for now, but you could totally get rid of those fractions altogether if you wanted. Now we're going to go back to our good old friend completing the square. It may have been some time since you've done this, and there are a number of ways to complete the square. But the way I'm going to do is I'm just going to move any constants over to the other side. So I'm going to have y plus 13/4. And then to complete the square, I'm going to do it this method. So in here, we take our b divided by 2, so -6 would be b divided by 2, and square it. So that would be 3 would be b divided by 2. When I square it, I would get 9. Right? So one of two ways you can do this. You would either add, right, 1/12 times 9 to this side, or since I added, I'm really adding 9 times 1/12. In the parentheses at the end, I'm going to subtract. And I actually want to do this first. 1/12 times 9. But you might have to maybe do a little completing the square Googling, or however you remember how you did it in Algebra 2. I have no preference as long as you can get to standard form. So now I'm going to clean things up. Over here, I'm just going to write this as 9/12 right now. My constant's all on this side. And now the whole point of completing the square was this could be x minus 3 squared, that nice binomial term we have in there. All right, so over here, if I add these together, this guy would be 39 over 12. So I'll get 48 over 12, which is really y plus 4. Now you guys will notice up in that box up there for standard form, I always have the coefficient, so this constant, on the non-squared side. So our final answer for this would be y plus 4, but this 1/12 I'm going to multiply over, so that squared binomial is by itself. All right, so let's write out some info. This would be a parabola that opens, since it's an x squared parabola, which is like our normal parabola. It opens up with our vertex, which is hk. So remember, h is always coming from the x variable. So 3, we change the sign, -4. This coefficient is 4p, so I'm going to say 12 equals 4p. So for us, p equals 3, which is distance from the vertex to the focus. And then I'm going to start graphing these things, and we'll write out some other info. So first I'm going to put the vertex on the graph. So 3, 1, 2, 3, 1, 2, 3, 4. I'll label that V for vertex. All right, I'm also going to put in the focus. So I use this distance, and since it opens up, I go up 3 from the vertex. So whichever way it opens, that's the way you would go. So 1, 2, 3. And here is the focus. And I'm just going to add that to my list here. So our focus looks like it's at 3, -1 to go through. Now, on our last sheet, we also saw the directrix, which I'm going to draw in here. And that's just the opposite direction of the focus. If I go up 3 to get to the focus, I go down 3 to get to the directrix. Looks like we're at -7. The directrix doesn't really help us graph, but it is involved in the definition of a parabola. So from our last worksheet, hopefully we saw that for a parabola, I'm going to put the definition over here. It's a locus, they call it, or just a set of points that are equidistant from a set point, which is the focus, and a set line, which is the directrix. So I'm going to draw this parabola in red, and we actually have the first point on the parabola, which is the vertex, because it's 3 units from the focus and 3 units from the directrix. Now there's a really nice other easy point to find, and that's going to be if I find a point that's in line with the focus, right? So if I'm going out to the right or the left, it needs to be, the point on the parabola needs to be the same distance from the focus as the directrix. So I kind of want to make like a square here. So it looks like this line would be 1, 2, 3, 4, 5, 6 units from our directrix. 1, 2, 3, 4, 5. Looks like my point's a little off. Should be right there. 6 units from our focus. And this is an easy distance to find. This distance is always going to be 2 times the p-value. So I'll count out 1, 2, 3, 4, 5, 6, and that will be another point on my parabola. This is also 1, 2, 3, 4, 5, 6, the same distance from the directrix. So those are 2 really easy points to find. 1, 2, 3, 4, 5, 6. Go and put one on the other side. And that's how we would graph in our parabola. So I'll always ask you guys to have the vertex, the focus, at least 2 points on the parabola, and your directrix. Right, so I'll label these points so it's a little bit easier to see. This guy is -3, -1, and this guy is 3 plus 6, I think 9. And you could always check them by subbing them back into your original equation. So I'm going to end this video here. I will do one more example for you guys in another video since this one's getting long. And let me know any questions.